welcome back to A Software Engineer Plays, the YouTube channel where a software engineer, that's me, plays through video games that are designed to teach you how to program. This week we are back in Human Resource Machine. The last episode we were looking at the Fibonacci sequence and recursion. We have one light left to turn on this problem, so let's see what we can do there. It's the number of block light. So you can see last time our solution involved initializing both A and B to be 1, and then adding it back and forth, setting B to be the sum, and then setting A to be the sum, and then every time subtracting the number to make sure that it was less than or equal to the number provided. So this is over by, 9 steps, so let's go ahead and start fresh, because why not? Now, an important thing to know, or to think about with the Fibonacci sequence, is there is technically a number off to the left here, which is still technically part of the sequence. So if you put a 0 at the very beginning of the sequence, then you have 0, 1, and the next number is the sum of those two numbers, right? Because 0 plus 1 is 1. So you can start off with a 0, which they've given us here. 0. And then you can do the same process with the 0. So I think what we'll want to do, we'll keep the same inbox copy to check stage, but then if we copy from 0, copy to A, and then copy to B and bump B, so make sure that works. Great. So that's all working. So now we have 0, 1, and our number. Now we can start doing our sum. And we've got 13 steps to do it in, so not feeling too bad about that. We want to, let's see, we have B in our hand, so we want to add A. And let's go ahead and copy that to, I don't know, let's call this guy temp. Just so we can see how it's working. So then that should get us a 1. We'll have 1 in temp. Then we want to do 0, 0, 1, add, store in temp. Okay, we're still holding the 1. So now we want to add B. And I guess we can copy back to temp. But the only problem with that is that we're not updating these numbers. So we don't want to copy to temp here, because then we'd have 0, 1. It just wouldn't work out. I'll show you why here. Let's step through it. So we get 0. We get 1. We get our 2 1s. Now we do this. We get 2. We store it in temp. Now we do have our initial number. We have our 1 here, so we can add, but then what needs to happen is we need to store it in B. Okay, so we'll go ahead and add B, and then copy to B. Fix that. Okay. So we've added. And I don't think we need the temp. We should be able to use A here. Okay, so that's working. Let's go ahead and make temp equal to A. Get rid of this label. Make sure that still works. Okay. So far so good. Good. Okay. So now we can do our subtraction from check. Well, actually, we need to do our subtraction from check every time through the loop, right? So... This seems like one step too many. Let's just make sure we've got this right. Add A, copy to A, add B, copy to A, add B, copy to B, add A, copy to A, add B, copy to A. Okay, so it's not quite right. Reason being, we get mixed up here, we lose track of ourselves. Let's see if we don't need those middle steps. Again, we're not going for speed, we're going for number of blocks here, so if it takes a little bit longer than it needs to... Okay, this is looking good. Yep. Okay, perfect. So that is working as expected. So now, at every point through here, we want to subtract the check. And if it's negative, we want to jump out, subtract check, jump if negative down to woo here. Okay. So if it's negative, that means... Ooh, this is not going to work for the case where we have an actual Fibonacci number. Because it's going to be 0. So one stupid, potentially, thing we could do is modify the check number so that it's never actually a Fibonacci number. If we add 1 to check, then even when we get the Fibonacci number, like in this case of 8, if we had 8 here and we made it equal to 9, then once we get 8 we would still get a negative number and the next number would be greater than it. Which could work, but let's see if we can come up with a more elegant solution than just adding 1 to numbers whenever we feel like it. Okay, so here, if it's negative, we want to continue. And here, if it's negative, we want to jump up to there. Don't need that one. So, to make our outboxing a little bit easier, we may want to copy this to a third, just so we can copy from the result an outbox. Let's call this result. So, I don't think this is going to work for cases like 8 here, because, well, we got a problem here. This jump if negative. See, we're already going to be over. That jump if negative is not super useful. We need to have a jump statement in the middle there to jump out of the loop. And now we are over our number of blocks, and it's not ideal either. Because, well, bad things are happening there. So let's reevaluate and see what we can do. mean, in a perfect world, we wouldn't need to flip-flop and have both of these sections. It would just be one loop. That would be quite handy, because, well, then we'd save on all these blocks, and we could just have one block looping around, which should save us a little bit of time. So let's see if we can come up with a solution that does that. I think for that kind of solution, we would need... Let's just get rid of all this stuff here at the end. So if we go A to B to result, and then result to B, let's think. Okay. So... Okay, that's another thing that I forgot, is that we have to outbox all of the Fibonacci numbers, so... we need to go ahead and put an outbox in there, because that's the first time we get a 1. Okay, so this will now output 1 all the time, which is great. 4. So now let's just start working the Fibonacci sequence through here. So we're gonna copy from A, add B, and we're going to store that in the result. Okay. Then we subtract the check number, and if it's negative, we what do we do if it's negative there? We'll work through that in a minute, but copy from... Okay, so we copy from A again, and just shift it across. And then... So we're going to do a little bit of a swap here, I think. So this is the swap that we talked about in earlier. So the result will always be... We're going to use 3 to sort of swap them around so that we can always do the same addition here. And then we're going to jump this up to here. We'll go ahead and do an outbox there as well. And then if this is negative, let's just move it down to the bottom of the program. We can see how it works here. Get 10, we do our initialization, get our 1, outbox the 1. Okay, now this is where it starts to get interesting. So we're going to do our first, store it in the result. Subtract check, and it is negative. So, what do we want to do there? We want to keep on going, so we don't need that block there. We're going to need a block eventually, but I think we're going to need it down here. subtract check and jump if negative. But we can't do that there because we're going to lose the value of the number we're holding when we go to the outbox. Okay. So... well, that's... okay, what if we do it the other way around? Instead of subtracting check, we subtract from check. So let's try that. We will copy from the result, or copy from check rather, and then subtract what we stored in the result. And then if that's negative, then we should be done. So let's try that. Okay. Alright. So stepping through here, we'll do our initialization, get our first number 1, send it to the outbox. And now this is where things start to get interesting. So we get our... we're going to add straight across and store in the result. Okay, so far so good. Now we're going to check to make sure that our result is not bigger than our check. So it isn't, so we continue. So we're going to do a little swap here. And we're going to copy the 1 over to A. And now we can outbox that number. And we're going to do the whole process over again. So we start by adding here. Add B. Copy to the result. I see a problem. And the problem is that we are looping forever. Why is that happening? And they're unhappy with us. Okay, so let's see if we can figure out why that's happening. This part's all fine. We get 0 there, we get 1 there, we get 1 in the results. Okay, that's all fine. And we get a 4 there, and we move it. Okay, so I think the problem here is that we don't actually want to overwrite the value of B like that. If we just put the results, I think we want to copy from the result and store it in A, and then let's think. Okay, so we overwrite here. We do not want to do that. Oh, I think this is the problem here. I think instead of copying to A, we want to copy to B. Does that make sense? Let's just make sure we have everything in the right order here. Okay. So the larger number is always in B in this circumstance. That's going to be a positive, so we keep on going. Okay. So B goes to A, result goes to B. Alright, this is looking good now. Okay. And now we continue. We get A, we get 2, we put it in the result, we do our subtraction, 19, we continue, move that over, move that over, ship it. Okay, so it's working. And I think because we subtract the number from check, we shouldn't ever have the problem where we get a Fibonacci sequence in as the check number. But you can see the number of swaps here is going to be doing quite a lot more steps of execution than our original solution. Also, it's using more memory, which, if that's a concern for you, is something to keep in mind. Okay, we're getting 5 now. And this is the iteration where things get interesting. We get an 8, do the subtraction, we get a 0, so it's not negative, so we're not done yet. We're going to do one additional reset of the memory and then outbox here. And now we have to do one more loop just to make sure that we're not greater. So more additional unnecessary steps at this point, because we could have just seen that we were at this point and be done with it, because it's a less than or equal to. So now that we're equal to the check, we should be done, but the code doesn't know that yet, because we have to get a value of result that is larger than check in order for this code to stop. That was one thing that our previous solution did account for, so our previous solution should execute faster than this because we didn't have to do all these extra steps. But we did do it in 19 steps, so 19, good, speed challenge. Okay, so came really close, we did it in 154. I think the previous solution was 104, considerably faster. Yeah, 104. So interesting that this solution completes both challenges. Kind of cool. Anyway, that completes both of those challenges for this problem. So I'm gonna call it a day for this video. Call it a day for the Fibonacci sequence. Thank you very much for watching. If you enjoyed the content, please like and subscribe, and consider sharing with your friend. You can compute the nth number of the Fibonacci sequence and share it with that many friends. Please choose a large number of n for that computation. Alright, thank you for watching. Bye.